Example 3.5. A battery of 10 volt and negligible internal resistance is connected across the diagonally opposite corners of a cubical network consisting of 12 resistors, each of resistance 1 ohm. Determine the equivalent resistance of the network and the current along each edge of the cube. Okay, if you carefully observe the diagram, it is clear now. Battery is giving the current 3I. That 3I is divided into 3 equal parts. Why? Because all the resistors are equal. As like this is Papaka property that will be divided for 3 children. Same way, the incoming current is 3I. It is divided into 3 branches equally. All resistors are equal. Now this incoming current at point A again divides at point A dash, it divides into 2 equal parts. Once again resistors are equal. So current I 50% will go here, 50% go here. Now I would like to change the incoming current because I don't want to show the fraction. So what I will do is I will take incoming current instead of 3I, I will take 6I. Can I take 12I? Can I take 24I? That is my wish. Because if I take 6I, you see how this distribution at point A, it will be divided into 2I, 2I, 2I. Then this 2I will come to point D. Here 2 branches. So 2I will divide into I and I. This 2I at point F divide into I and I. This 2I at point B divides into I and I. Now you come to this branch. Here what happens? This is I and this current I, incoming current I plus I. So outgoing should be 2I. Same way at point E, I and I is incoming, outgoing is 2I. Similarly at Q, I and I incoming, outgoing is 2I. At point C, outgoing is 2I, 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 6I. Incoming is 2I, outgoing is 6I. That is your wish. Incoming current, you can take any current that is actually unknown. But if you take 6I, no fraction here. So easily we can solve. Both are okay. You can take 3I or 6I. Now I'll proceed with the incoming current 6I. Okay. I will use the formula Kirchhoff's second rule, sigma E equal to sigma IR form. Let us consider the loop A, P, Q, C, B and back to A. The last loop, this one. Now, here voltage drop, that is V equal to IR formula. Current is 2I, resistance is R, 2I into R. Here I into R, voltage drop is I into R. Come to this here, 2I into R. That's all. That is equal to algebraic sum of EMF is E. I'm moving from negative to positive, so EMF is E. 2I into R, that is 5I R equal to E. Now I'll substitute E value, that is 10. 5I R equal to 10. But what is given in the question? R value is 1 ohm. So we substitute. So I'm getting 5I equal to 10. Therefore, I equal to 2 ampere. I equal to 2 ampere. What is the total incoming current? What I assumed 6I is the incoming current. Therefore, I total is 6 into I. I got I as 2 ampere. I total becomes 6 into I, that is 12 ampere. Now, what is the equivalent resistance? We will use Ohm's law. V equal to I total into R equivalent. I would like to find out R equivalent. That's now I'll substitute. Voltage is given as 10 volt. I total is 6I. Please note the point. I total is not 2I. 2 ampere. I total is, in my diagram, I marked 6I. So 6 into I is 12. Into R equivalent, we don't know. If you simplify, I'm getting R equivalent is equal to 10 by 12. That is 5 by 6 ohm. So R equivalent resistance is 5 by 6. I hope it is clear.